Today we're going to learn how to simplify square roots. And we'll take a quick look at multiplying square roots, and at the same time we will simplify those square roots. The secret to understanding square roots is perfect squares. A perfect square is any number times itself, like 1 times 1 is a perfect square, 2 times 2 is a perfect square, 3 times 3, 4 times 4, 5 times 5. These numbers are really important when you simplify square roots. So we got 49, 64, 81, 100, 121. That's 11 times 11. 144, 12 times 12, 13 times 13 is 169. 14 times 14 is 196. 15 times 15 is 225. 16 times 16 is 256, and so on. You need to be able to recognize these numbers to simplify square roots. Any of these numbers, if we get a square root containing them, like the square root of 4, we know that any number times itself is a perfect square, and the square root of 4 is 2, because 2 times 2 is 4. The square root of 9 is 3. The square root of 100 is 10. If I ask you to take the square root of, say, 3, you can't do that unless you approximate. And a lot of times in mathematics, we want to keep our answers exact. That's why we simplify square roots. The square root of 50. We can't make that a whole number, but we can simplify it. And the way we simplify it is we find one of these numbers that divides evenly. Now, ideally, you want the biggest number, or you're going to have to take multiple steps. Find the largest number in this list. Keep in mind the list keeps going, that divides evenly into 50. And that number would be 25. I can rewrite 50 as 25 times 2, same thing. I can take the square root of 25 and take it out front, and when I do that, the square root of 25 becomes 5, and left underneath the root is still the 2. Now this 5 root 2 is 5 times root 2. Remember, there's multiply here. If you punch this in the calculator and look at the decimal, and you punch this in the calculator and look at the decimal, you'll see they're the same decimal, but this one is simplified. The square root of 24. Find the largest number on this list that divides evenly into 24. And that would be 4. I can rewrite 24 as 4 times 6. I can take the square root of 4. The square root of 4 is 2. 2 root 6 then is my answer. And 6 has no perfect squares in it. It's 2 times 3. Both of those are prime numbers. The square root of 8. The largest perfect square that divides into 8. Just start at the beginning of the list. 1 isn't very useful, by the way. Just start at 4. 4 divides into 8 evenly. And that's the largest number on the list that divides into 8. I rewrite it as 4 times 2. The square root of 4 would be 2. That goes out front. Remember, there's times here. We don't write that dot, but it's there. Left underneath the root is that 2 that I can't take the square root of. The square root of 32. Now you might immediately go to 4, because 4 times 8 is 32. The issue is, if you look at 8, there's still a number on this list of perfect squares that divides evenly into 8, and that would be 4. 8 is 4 times 2. Whenever the number remaining still has a perfect square in it, you know there's a larger perfect square. In fact, it's going to be 4 times 4 is 16. 16 is the largest perfect square in 32. I'm going to rewrite that as 16 times 2, and the square root of 16 is 4. So 4 root 2 is my answer. If I ask you to simplify the square root of 200, you start at the beginning of the list and go up and find the largest one. 4 goes into 200, 4 times 50. But if you think of it as 4 times 50, 50 has another perfect square in it. It has 25 in it, 25 times 2. So there's a bigger one. In fact, notice how 4 is a perfect square, and 25 is a perfect square. It turns out if you multiply two perfect squares, you get another perfect square. 4 times 25 is 100. 100 is the largest perfect square in 200. So I'll rewrite this as 100 times 2. The square root of 100 is 10. It goes out front. Left underneath the root is a 2. 10 root 2 or 10 radical 2. You can also call that's the radicand. 10 radical 2 is another way to say that. If we had the square root of 72, you might go up the list, and remember 1 isn't very useful. Start at 4. 4 times 18 is 72. Well, 4 isn't the biggest, and I can tell because 18 still has a perfect square in it on the list right there, 9. 9 times 2 is 18. Since 4 goes into 72 and 9 goes into 72 and both are perfect squares, 4 times 9 goes into 72, and that would be 36. I can rewrite 72 as 36 times 2. I can take the square root of 36, goes out front, it would be 6. 6 root 2 then is my answer. Remember, it's got to be on this list. If it's not on this list, you don't use it to simplify. Let's point out that if you took the square root of 72 and you made it 4 times 18, and you didn't notice that 18 had another perfect square in it of 9 that went in evenly, you said the square root of 4 was 2, and you said, hey, it's 2 root 18. This is not simplified. It can be fixed, though. Remember, there's times right here. You could rewrite this as 9 times 2, that 18. I can take the square root of 9. When I take the square root of 9 out front, I have to multiply because there's times right there. Square root of 9 is 3. The 3 goes out front, and you multiply. 3 times 2 is 6. 6, and left underneath the root is still that 2 I couldn't take the square root of. I get the same answer either way. A few more examples, and notice all these have a number out in front of the root. Remember, there's times between that number and the root. 5 root 27. Go up the list, find the largest number that divides evenly into 27. 1, 4, 9 goes into 27. I can rewrite 27 as 9 times 3. I can't take the square root of 3, but I can 9. The square root of 9 is 3. I take that out front as a 3. There's times right here, so 3 times 5 ends up being 15. Left underneath the root is still that 3 I couldn't take the square root of. 15 root 3 is my answer. 7 radical 40. Remember, we can say radical instead of root. It's the same thing. 7 radical 40 is 7 times radical 40. And I can rewrite 40 because there's a perfect square in it. Go up the list. Looks like it's 4. 4 goes in evenly. 4 times 10. 10 is 2 times 5. And neither of those contain any perfect squares. I'll take the square root of 4 out front. Square root of 4 is 2. Don't forget to take the square root. There's times right here. 2 times 7 is 14. Left underneath the root is still that 10 that I couldn't take the square root of, nor simplify. Negative 4 root 98. The largest perfect square in 98, I believe, is 49. And the square root of 49 is 7. So let's not get ahead of ourselves, though. 49 times 2 is 98. As I said, the square root of 49 is 7. There's times right there, so I'm going to take that 7 and multiply. 4 times 7 is 28. Don't forget the negative, negative 28. And left underneath the root is that 2. Negative 28 root 2. A few more examples of simplifying square roots. 5 root 9, 5 radical 9, remember, is 5 times the square root of 9. This is 5 times the square root of 9 is a whole number, 3. And 5 times 3 is 15. 5 root 9 is equal to 15. 8 root 4, that's 8 times the square root of 4. and the square root of 4 is 2. 8 times 2 is 16. Root 7 squared. That's root 7 times root 7, which is root 49. And the square root of 49 is 7. Root 7 squared is 7. 2 root 5 squared is 2 root 5 times 2 root 5, which is 4 root 25. 4 root 25 is 4 times the square root of 25. Square root of 25 is 5, and 4 times 5 is 20. 2 root 5 squared is root 20. 6 root 3 squared. That's 6 root 3 times 6 root 3. We multiply the whole number parts. That's 6 times 6 is 36. Multiply the root parts. Root 3 times root 3 is root 9. This is 36 times the square root of 9, which is 3. And 36 times 3 is 108. This one looks complex. It is not. When you get a fraction under a root, you just split up the root. It's root 4 over root 25. The square root of 4 is 2, and the square root of 25 is 5. So the square root of 4 25ths is 2/5. When you multiply square roots, you can multiply a square root by a square root. That's the root part, a root by a root. And the number out front, an integer, that's a positive and a negative. You can multiply the integer by the integer. Be aware you can't multiply a integer by a root. 5 times root 7, you can't do that. 5 times root 7, in fact, is 5 root 7. You might think, hey, I just multiplied those two, but you didn't. 5 times root 7 equals 5 root 7 is still 5 times root 7. You drop the dot. There's no difference between those. It's just like if I ask you to multiply 3 times x and you write it as 3x, you didn't do anything. It's still 3 times x. You just dropped the dot. You cannot multiply a whole number or an integer by a root. It does not work. In other words, 5 times root 7 is not, and I repeat, not root 35. Those are not the same thing. Check it on a calculator. Don't do it. If you have 3 root 5 times 4 root 7, you can do that though. You can take 3 times 4 because you can multiply in any order. Remember, this is 3 times root 5 times 4 times root 7. 3 times 4 is 12. Root 5 times root 7, yes, that's root 35. Root 2 times root 3, you can do that. That's root 6. The thing you have to watch out for is that after you multiply, quite often, you'll need to simplify your square root. If I ask you to take root 2 times root 10, yes, that is root 20, but root 20 has a perfect square in it. Remember the list on the previous page? 1, 4, 9, 16, 25, 36, 49. 4 divides evenly into 20. I can rewrite 20 as 4 times 5, and I can take the square root of 4. The square root of 4 is 2. That goes out front because I took the square root. Left underneath then is the 5. Root 2 times root 10 is 2 root 5. Negative 3 root 8 times negative 2 root 7. That would in fact be positive because a negative 3 times a negative 2 is positive 6. And root 8 times root 7 is root 56. Now I'm going to look at 56 and see if I can find any perfect square in it. I go up that list, forget 1. 1 isn't very useful. Start at 4. Does 4 go into 56? It does. This is 4 times 14. I can take the square root of 4 is 2. That goes out front as a 2. Left underneath then is 12 root 14. A better way to do that question is probably not to do this. Always look at the question before you do anything. Can you simplify the pieces first? And the answer is yes, because 8 has a perfect square in it. I can see that. 8 is 4 times 2. And I can take the square root of 4 out front and multiply. Square root of 4 is 2, multiply. This becomes negative 6 root 2 times negative 2 root 7. I can take negative 6 times negative 2, that would be positive 12, and root 2 times root 7 is root 14. Simplify right off if you can. That'll a lot of times make your question easier and you don't get large numbers that are harder to find perfect squares in. Sometimes you can spot perfect squares before you multiply. Neither 5 nor 30 have a perfect square in it, but 5 has that 5, a factor of 5, and 30 also has a factor of 5. That's going to make a perfect square of 25 when you multiply. Notice these are both roots. I can multiply them. This is root 150. Since there were two factors of 5 in each number I multiplied, that made a perfect square of 25, and I can rewrite this as 25 times 6 is 150. The square root of 25 is 5. I'll take that out front as a 5, and I'm left with 5 root 6. The remainder of this video is questions from your assignment. Question 1. The first thing you want to do is check to see if your square root is a perfect square. Is it a number that's on this list? Because if it is, I get a whole number answer. The square root of 100 is what number times itself is 100? That would be 10. The square root of 81 is what number times itself makes 81? That would be 9. And the square root of 25 is 5. Question 2. Notice how the square root of 9 is a perfect square. It's on this list right there. This is 9 times the square root of 9, which is 3. And 9 times 3 is 27. Question 4. When you get a fraction under a square root, you can split up the roots. This is the square root of 9 over the square root of 100. Same exact thing. Square root of 9 is 3, square root of 100 is 10, so the answer is 3/10. Question 9. The square root of 175. We're looking for the largest perfect square that divides evenly into this number. We're not going to have any decimals. Start up the list and see if the number divides evenly into 175. 4 does not go into 175, neither does 9 or 16. 25 does. I can rewrite 175 as 25 times 7. Square root of 25 is 5, so my answer is 5 root 7, or 5 radical 7. 22 radical 98. 98 has a perfect square in it. 4 does not divide into 98, neither does 9, nor 16, nor 25. 36 doesn't divide into 98. 49 does. I'll rewrite this as 22 and 49 times 2. That's 98. The square root of 49 is 7. I'll take that 7 out front and I'll multiply. 7 times 22 is 154. 154 radical 2 is my answer then. Question 11. 7 radical 162. Start up the list, find the largest perfect square that divides evenly into 162. 4 does not, 9 does. Notice that if you take 162 and divide it by 9, it turns out to be 9 times 18. I can tell 9 is not the biggest perfect square because there's another perfect square in 18. 18 is 9 times 2. Notice these two perfect squares, 9 times 9. That's 81, another perfect square. In other words, I can rewrite this as 81, and 81 goes into 162 twice. 81 times 2. The square root of 81 is 9. The 9 goes out front. 9 times 7 is 63. 63 root 2 is still my answer. I still have that 2 left under the root. 11 root 50. 50 has a perfect square in it of 25. This is 11, and 25 times 2 is 50. The square root of 25 is 5. I'll take that 5 out front. Remember, there's times right there. 5 times 11 is 55. 55 root 2, then, is my answer. Question 13. Notice how 3 and 11 are both prime numbers. When I multiply 3 and 11 and get 33, it is not going to have a perfect square in it. What I'm going to do here is multiply the whole number times the whole number. It's an integer also. The integer times the integer, 9 times 10, that's 90. And I'll take root 3 times root 11, and that's root 33. This cannot be simplified because there's no perfect squares in 33. It's 3 times 11, both are prime numbers. Root 7 times root 77. See how 77 has a 7 in it? It's 7 times 11. I'm going to end up with 2 7s, which means whatever I multiply this out to be, it's going to have a perfect square of 49 in it. 7 times 77, get out the calculator, is 539. 539. We know that it's going to have 2 7s in it. It's going to have a perfect square of 49 in it. 49 times 11, in fact, we can see that because it's right there. If I take 539 divided by 49, I'm going to get 11. The square root of 49 is 7. Left under the root is 11. 7 root 11 is the answer. Radical 2 times radical 14. That would be radical 28. Notice how 14 is 2 times 7. It has a 2 in it. And these two 2's make a perfect square of 4. 4 times 7 is 28. 4 is a perfect square. I need perfect squares to simplify a root. It's got to go in evenly, and I want the largest possible. Square root of 4 is 2. 2 root 7 is the answer. Question 18 turns out to be an easier question. You need to remember that if I ask you to multiply 5 and root 2, you can't do that. You can say it's 5 root 2, but you didn't do anything. You dropped the dot. It's still 5 times root 2 when you write 5 root 2. And that's not what this question is, but it's the same idea. I can multiply these two integers. An integer is like a whole number, but it can be negative. Negative 3 times negative 13 is negative 39 root 6. I can't multiply that 39 and that root 6 because they're not both roots. They're an integer and a square root. Question 19 and 21, you're going to end up with questions like this in our geometry homework at some point. They turn out to be easier than you would think. Root 7 squared is root 7 times root 7, which is root 49. But the square root of 49 is 7. And yes, a square and a square root are inverses of each other. They, in effect, cancel each other out. So the square root of 7 squared is 7, just like the square root of 9 squared would be root 81, which is 9. And the square root of 10 squared would be the square root of 100, which is 10. 9 root 2 squared is 9 root 2 times 9 root 2, which is 81 root 4. 9 times 9 is 81. Root 2 times root 2 is root 4. Square root of 4 is a perfect square because, of course, these two numbers were the same number. This is 81 times the square root of 4, which happens to be 2. 81 times 2 is 162. I will point out that this is not necessary. You can go right here and just say, I'm going to square the 9, that's 81. I'm going to square the root 2, that's root 4. And then realize that that is 81 times 2, which is 162. Last two examples. My advice is to start looking for a perfect square before you do the question. Notice how 12 has a 4 in it. It's 4 times 3. Hey, there's a perfect square. Ooh, look at that. 3 and 3 are going to make another perfect square. Watch what happens. 5 times 2. Hey, that's 10. Root 12 times root 3 is root 36. Square root of 36 is a perfect square because it was 4 times 3 times 3, 4 times 9, both perfect squares, which made 36. This is 10 times the square root of 36, which is 6, which happens to be 60. Question 24, I'll multiply the whole numbers. 9 times 5 is 45. I'll multiply the roots. 3 times 21 is 63. A lot of times you can look here and look for a common factor. 3 and 21 is 3 times 7, and these two 3's are going to make a perfect square of 9. This is 45, and 9 times 7 is 63. The square root of 9 goes out front as a 3. There's times here, remember. 3 times 45 is 135. Left underneath the root is that 7. 135 root 7.